Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA 2021 Combined Science or the Trilogy Physics Paper 1 higher tier. Question number 2 is on the topic of atomic structure, mainly focusing on nuclear radiation. A radioactive source emits alpha, beta, and gamma radiation. So remember the symbol for alpha, beta, and gamma radiation. An alpha particle is the same as a helium nucleus. Now, if it's a helium nucleus, if you think back to your periodic table in chemistry, that's the information that you get in the periodic table. What this suggests is that a helium nucleus has 2 protons and 2 neutrons. So 2 protons and 2 neutrons. Because it's the nucleus, it's not the atom, it doesn't have any electrons. How many times bigger is the radius of a helium atom than the radius of a alpha particle? Now remember, the alpha particle is the helium nucleus. That's what they've just said here. So what they're asking you to compare is the size of the helium atom. How many times is the radius of a helium atom compared to the helium nucleus? Now, if you think about the nucleus in any atom, which is in the center, you can measure the diameter of that. And what they're asking is, if that's the size of the atom, what is the size compared to the entire atom? Right? Now, generally, for all types of atoms, the nucleus is about 10,000 times smaller than the atom itself, or the other way around. The atom is about 10,000 times bigger than the nucleus. So the answer is more than 10,000 times bigger. Question 2.2. Alpha particles can ionize atoms in the air. So remember again, in terms of chemistry, ionize is to add or remove electrons from another atom. An ion, on the other hand, is when an atom loses or gains an electron. So here what they're saying is an alpha particle can ionize, which means it can add or remove electrons from atoms in the air. What happens to an atom when it is ionized by an alpha particle? Now, is the alpha particle going to add or remove electrons? Now, that depends on the charge of the alpha particle. Remember, an alpha particle is a helium nucleus. So it has 2 protons. That's the proton number, 2 protons. Now it doesn't have any electrons. These 2 protons have each has a positive charge. So a helium nucleus or the alpha particle has a charge of +2. So an atom would be neutral here. So if the alpha particle has a charge of +2, it is looking for electrons to neutralize this +2 charge. So it's going to remove electrons from an atom. So a neutron in the atom becomes a proton. That's not what's happening. The atom becomes a positive ion. Now, that is correct. So if an alpha particle gains an electron, the other atom is actually losing that electron, which means that becomes a positive ion. The atom gains a neutron, no. The atom gains a proton, no. The atom loses an electron, which is correct. Because it's losing an electron, it will become a positive ion. So remember, they are asking you to tick 2 boxes for the 2 marks. Next question. 2.3. The answer is already there. Now, A spark detector is a device that can be used to detect alpha radiation. A spark detector works by alpha particles ionizing atoms in the air near a wire mesh. A large potential difference creates a spark when the air near the wire mesh is ionized. Suggest why a spark detector cannot detect a beta radiation. The main reason being beta radiation is only weakly ionizing. Remember, beta radiation is a fast moving electron. So that's a fast moving electron with a negative charge, right? Because it's only minus or one negative charge, because it's an electron, it depends whether it can ionize or not. It depends on the atom wanting that electron or not. So hence, that's why it's weakly ionizing. Next question. Question 2.4. A teacher wants to demonstrate that the radioactive source emits alpha, beta, and gamma radiation. Figure 3 shows the equipment the teacher has. So you've got 3 millimeter thick aluminium sheet, a thin sheet of paper, radioactive source in a holder. So that's where the radioactive source is, and it's going to come from the front in this direction. And you've got the radiation detector. Now here they're saying a radiation detector. The proper name would be a GM counter, and the counter rate meter. So this, you're going to have numbers which is given depending on the number of particles that is being detected. Now, describe a method the teacher could use. What is the teacher trying to do? The teacher is trying to demonstrate that the radioactive source emits alpha, beta, and gamma, all three of them. How can you detect alpha, beta, and gamma? Well, the radiation detector will detect all three particles when they are coming through. So why do you have the thin sheet of aluminium and paper? Now, paper will stop alpha particles, but it will actually let through the beta particles and the gamma particles, because alpha is actually just stopped by a thin sheet of paper, but paper is not thick enough to stop the beta and the gamma. A thin sheet of aluminium, on the other hand, will stop the alpha and the beta, but it will let through the gamma radiation. To stop the gamma radiation, you will need a thick sheet of lead, or thick piece of lead. Even then, it might let some of the gamma through. So how would the teacher actually do this? Now, first thing is to actually move the radioactive source right in front of the detector, which is probably about a centimeter in between. You don't want to keep it far away, because alpha and beta has a very short range, less than 10 centimeters. So you want to keep it as close as possible. That's the first thing that the teacher should do. They need to move the radioactive source quite close to the radiation detector, so that the radiation detector is measuring all of the radiation that is coming from the source. So let's say it's measuring 1,000 becquerels. That's becquerels is a unit of measurement for radioactivity. So the unit is BQ. So let's say it's measuring 1,000 becquerels without anything in between. Then what you would do is put the thin sheet of paper in between the source and the detector and find out what the reading is. Now, if the reading, let's say it goes down, let's say to 600, what that means is that the source is actually giving out alpha particles. That's why is gone down by 400. Now beta and gamma will still go through, hence you got still 600 becquerels coming through. Then you would remove the paper and put the thin sheet of aluminium in between. If you put the thin sheet of aluminium in between, if the number goes from 1000 to, let's say, 200 becquerels, instead of 600 with the paper, now it's gone down to 200. That means it's actually stopped some more particles. And that basically tells us that the source is giving out alpha and beta radiation. Now, what does this 200 mean? Because there's still some radiation coming through, which is registering as 200. If there is still a reading on the meter, that means that some radiation has managed to get through even the thick sheet of aluminium. That shows that the source is also giving out gamma radiation, because gamma radiation is not going to be stopped by the thin sheet of aluminium. So what the teacher can do is actually do this step by step. First, put the thin sheet of paper in front of it, record the count rate, right? And then replace it with the aluminium sheet. And then they would actually have to repeat it about 2 or 3 times, because remember, radiation or radioactive decay is a random process. So how would you write an answer for this 6 marks? So let me show you a model answer. First point, move the detector very close to the source and record the count rate. That should give you 1 mark. That's the first step. Then position the paper between the source and the detector and record the count rate. If the count rate in the paper is significantly less than without the source, than without the paper, meaning not the source. Let me repeat that. If the count rate with the paper is significantly less than without, then the source emits alpha radiation, since alpha radiation will not penetrate through paper. That gives you another mark. Well, that should actually give you 2 more marks. Next, remove the paper and position the aluminium between the source and the detector and record the new count rate. If the count rate has significantly reduced compared with using the paper, then beta radiation is also present, since both alpha and beta radiation will not penetrate through the aluminium. That should give you another mark. If radiation still penetrates through the aluminium, then gamma radiation is present as well, since aluminium does not stop gamma. That gives you the 5th mark. And for the 6th mark, you need to mention the experiment should be repeated and mean results calculated, because radioactivity is a random process. That gives you the 6th mark. That brings us to the end of question number 2, and I will see you in question number 3.